Good morning. I, Professor Arvind Muddebihar from the Department of Mechanical Engineering, welcome you to the subject Design of Machine Elements 1. In the previous video, we have studied about the engineering materials and mechanical properties of materials. So today in this video, we are going to study about the stress strain and the tensile test, the stress strain curve and properties which are determined in the tensile test. After that, we are going to study about the codes and standards which are used in the design process. Also, we are going to study what are the importance of these codes and standards used in the design process. Let us start with the basics. What is stress and strain, which you have already studied in the your third semester mechanics of material subject. So stress is the intensity of internally distributed forces that tend to resist the change in shape of a body is called as stress. Here in the figure you can see that a member is subjected to a tensile load. So here you can see that the stresses are developed internally to resist the deformation. So this is called as a stress and which is calculated as stress is equal to load divided by area. And similarly we have a strain. When a force or load acts on a body, it undergoes the deformation. The deformation per unit length is known as a strain, and strain is a unitless parameter and it is calculated as change in length to the original length. Here this figure shows the universal testing machine where a tensile test is carried out. So this is the tensile specimen of made of, we can consider it is made up of a mild steel. Next we'll see the stress strain curve for this tensile test. The figure shows a stress strain curve. The mechanical properties are commonly determined from a standard tensile test. The testing machine is called universal testing machine. The test consists of gradually loading a standard specimen. So when standard specimen is gradually loaded, the corresponding values of load and elongation until the specimen fractures will be noted down. The load is applied and measured by a testing machine. The stress is determined by dividing the load values by the original cross-sectional area of the specimen. The elongation is measured by determining the amount that two reference points on the specimen are moved apart. The original distance between the two reference points is known as gauge length. The strain is determined by dividing the elongation values by the gauge length. Next, the values of the stress and the corresponding strain are used to draw the stress strain diagram of the material tested. Here in this figure what you are seeing the stress strain diagram, it is conducted for the mild steel. The various properties of material are now can be discussed. So in the figure from the point O to point A, the curve is a straight line. That is, stress is directly proportional to strain. Therefore, it is clear that Hooke's law holds good up to the point P. This point is known as proportional limit. It is defined as a point at which the stress begins to deviate from the straight line. Next, we have a region between point A and B. This region is known as the elastic limit, where material will regain its shape and size when the load is removed. It means that the material has elastic properties up to the this region. This point or this region is known as the elastic region. After the elastic region, we have the yielding region. If the material is stressed beyond the elastic region, the plastic stage will reach. On the removal of the load, the material will not be able to recover its original shape and size. At the point B, there is an increase in the strain without appreciable increase in the load. Thus, the curve drops down to the point C. Then again, there is a increase in the load, strain increases is practically constant up to the point C. This phenomenon of increasing strain without any appreciable increase in load is called as yielding. The upper yield point is called as point B and the lower yield point is called as point C. In practice, the lower yield stress is more important and hence this point is called as the yield point. Next, we have the region between point C to point D, where the point D is called as the ultimate strength. Between point C and D, the ductile extension takes place. Here, the relationship between stress and strain depends upon the rate of loading. During the extension of cross-sectional area decreases uniformly all over the length such that the volume remains constant. At the point D, the stress attains its maximum value, which is known as ultimate point. The stress at this point is known as ultimate stress. It is defined as the maximum stress obtained by dividing the maximum value of the load reached to the original cross-sectional area of the test specimen. After the ultimate strength, here we have the point E, which is known as a fracture or breaking stress. After the maximum load is reached, local yielding takes place and a neck or waist is formed. As the cross-sectional area decreases considerably, the load carrying capacity of the specimen reduces, and hence in the portion BE, the strain increases for decreasing stress. Even though the nominal stress is decreasing, the actual stress will be equal to the load divided by actual cross-sectional area at the neck will be continuously increasing. At the point E, specimen breaks. The stress at the point is called breaking stress and the corresponding load is called as breaking load. The nature of fracture of mild steel will be in the form of cup and cone. The region which you can see in the yellow shade is known as the elastic region. And in the figure, the toughness region is also you can see. The toughness is represented by the area under the stress strain curve which is shown in the figure. So this is the region of the toughness. In the exam point of view, you can take or you can give more importance to this particular topic as this particular topic is asked many times in the question paper about explaining the stress strain curve for the mild steel and asking the important properties of the material. So you should be able to draw this stress strain curve and write down the properties, important properties which are discussed in this video. So here we can also see that the Young's modulus of the material, which is given by stress divided by strain, which is the one of the important parameter of the material. So next we'll go to the course and standard which is required for the design process. Next we have the topic codes and standards. So code is a set of specifications for the analysis, design, manufacturing and construction of something which is related to the structures. So the main purpose here of the code is to achieve a specified degree of safety. With using the standard codes, we can assure the quality of the product in terms of its safety, in terms of its performance. As the performance increases, we can say that efficiency is high, and in terms of quality means the life of the product. So using this standard codes, we can assure the overall quality of the product. The next we have the standard. Again, standard is also a set of specifications of parts, materials or process which intended to achieve uniformity and specified quality of the product. Again, these standards are also used for assuring the best quality of the product. So standardization is defined as a compulsory norms to which various characteristics of a product should comply with the standard. Actually, the standardization is aims at establishing mandatory norms standard to which the different types, grades, parameters such as length, diameter, etc., quality, characteristics, test methods, rules of making, packing, storage of finished items, raw materials, and semi-finished articles should be confirmed. The one more main purpose of this standardization is to minimize the variety in the products. There are mainly three types of standards which are used in the design process. The first one we have company standards. These company standards are used in a particular company or a group of sister concerns. So these company standards are with respect to the individual companies what they will be adopting in their companies. Next we have the national standards. In the national standards we have BIS, that is Bureau of Indian Standards, which is used by our nation India. Next we have Germany. In the Germany we have BIN, and next in the USA we have AISI, that is American Iron and Steel Institute, or we have SAE, that is Society of Automotive Engineers. Next in the UK we have BS, that is British Standards. These individual standards are used by respective countries for their products to assure the quality and efficiency of the product and to maintain the standard dimension and specification of the products. The Bureau of Indian Standards, which is used in India, has a number of benefits for the designer. They are like rules for preparing the drawings is again one standard. The symbols and the notations for mechanical quantities and their units, engineering materials, their chemical composition, mechanical properties, method of heat treatment and methods of mechanical testing. Again, all these are defined by the BIS. Again, dimensions and preferred sizes of various machine components, fits and tolerances for various machine elements from assembly consideration. So this is all defined by the BIS, which will help the industries for importing and transporting of the material, and which also helps the industries for easy assembly of the machine components. Finally, we have the third standard, that is known as the international standards. These are prepared by the International Standards Organization known as ISO. So what are the benefits of this standardization? If you list the benefits, here we have the first one: reductions in types of dimensions of identical components. So this helps the manufacturer to easily import the components for their machine parts and assemble the things, or if they are manufacturing some parts and which they are exporting, the export after exporting, the one customer can easily take these components to fit into their machine parts. So that will reduces the types and dimensions of the in the variety of the components. Next we have reduction in manufacturing facilities. The next advantage is the reduction in manufacturing facilities. As the variety of components are reduced, there are only specific components are there, then the manufacturing facility will be restricted to manufacturing only those components. So that is nothing but as the number of varieties reduces, there will be reduction in the manufacturing facilities. So next we have easy to replace, that is interchangeability. So when we are producing the standard components, when we are importing or exporting the standard components, then there is no need of testing the elements, or uh, there is no need of any inspection of the materials. These these components will come under the standard manufacturing process and will be having all the quality characteristics which can be directly assembled into the machines. So there is no test for the design aspect. Next, it improves the quality and reliability of the product. So by manufacturing the standard quality of the components, even the companies can improve their reputation in the market for manufacturing these standard components. Also, it ensures the safety of the product, and it results overall cost reduction as the varieties and types of the materials and manufacturing facilities are reduced. The overall result will be the product will be ensuring the highest safety and within the low cost. So these are the benefits of the standardization. So in this video we have studied about the stress strain and stress strain curve and its importance, the standard testing machines, and codes and standards, benefit of standardization. The stress strain curve which we have discussed is quite important in the exam point of view. The various material properties which we discussed under this topic, students are required to go through those important properties and should be able to represent in the examination. Also, this course and standards and benefits of standardization is also one of the important topic. So if you have any queries regarding these topics, you can revert back. So here we conclude this video here. In the next video, we'll see the different types of loadings. Thank you.